According to the National Electrical Code, all electrical work in a new house must meet the current requirements of the code. This encompasses any rewiring or additions made to existing electrical systems. Generally, tapping into existing wiring in a 90% new house is not permitted. The rationale behind this restriction is that the existing wiring might not adhere to current code standards, potentially creating a safety risk. There are a few exceptions to this rule. Firstly, if the existing wiring is in satisfactory condition and complies with current code requirements, it might be acceptable to tap into it. However, it is crucial to have a qualified electrician inspect the wiring before proceeding. Secondly, if the existing wiring is situated in an area unaffected by the remodeling, it may be feasible to leave it in place and connect the new wiring to it. Once more, seeking an inspection from a qualified electrician is advisable. In most scenarios, running all new electrical in a 90% new house is a requirement. This includes wiring for lighting fixtures, outlets, switches, and all other electrical devices. To guarantee adherence to the National Electrical Code and to ensure the safety of our home, it is strongly recommended to install all new electrical wiring in a 90% new house. This practice helps prevent potential electrical hazards and ensures the electrical system meets current code requirements. Now, let's delve deeper into the specifics of the National Electrical Code and its implications for electrical installations in newly constructed or extensively renovated homes. The National Electrical Code, or NEC, serves as the benchmark for safe electrical design, installation, and inspection to protect people and property from electrical hazards. It is updated every 3 years to incorporate new technologies and address emerging safety concerns. The NEC is not federal law, but it is widely adopted by states and municipalities as their electrical code. When dealing with a house that is 90% new, the electrical system essentially needs to be treated as a new installation. This means that the entire electrical system must comply with the latest edition of the NEC adopted by the local jurisdiction. This requirement extends to the service entrance, grounding system, wiring methods, overcurrent protection, and all electrical equipment. The reason for this stringent requirement is to ensure that the electrical system is safe, reliable, and capable of meeting the demands of modern electrical appliances and devices. Older wiring systems may not have the capacity to handle the increased electrical load of today's homes, and they may also lack essential safety features such as ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or RFCIs. Tapping into existing wiring, even if it appears to be in good condition, can introduce several problems. Firstly, the existing wiring may be undersized for the intended load, which can lead to overheating and fire hazards. Secondly, the existing wiring may have deteriorated over time, compromising its insulation and increasing the risk of electrical shock. Thirdly, the existing wiring may not be properly grounded, which can also create a shock hazard. While there may be limited exceptions where tapping into existing wiring is permitted, these exceptions are subject to strict conditions and require careful evaluation by a qualified electrician. The existing wiring must be in excellent condition, it must meet current code requirements, and it must be properly protected by overcurrent devices. Furthermore, the additional load imposed by the new wiring must not exceed the capacity of the existing wiring. In situations where the existing wiring is located in an area that is not being remodeled, it may be possible to leave it in place and connect to it from the new wiring. However, this approach is not recommended unless the existing wiring is thoroughly inspected and tested by a qualified electrician to ensure that it meets all applicable code requirements. It is important to understand that the electrical system is an integrated network, and any modifications or additions can affect the performance and safety of the entire system. Therefore, it is always best to err on the side of caution and run all new electrical wiring in a 90% new house. This approach provides the greatest level of safety and ensures that the electrical system will meet the demands of the home for years to come. When running new electrical wiring, it is essential to follow all applicable code requirements and best practices. The wiring must be properly sized for the intended load, and it must be installed in accordance with the NEC wiring methods. All connections must be made with approved connectors and devices, and the wiring must be protected from physical damage. Grounding is a critical aspect of electrical safety, and it is essential to ensure that the electrical system is properly grounded in accordance with the NEC. The grounding system provides a low impedance path for fault current to return to the source, which helps to protect people and property from electrical shock and fire hazards. Ground fault circuit interrupters, or GFCIs, are another essential safety device that are required in many areas of the home, such as bathrooms, kitchens, and outdoor locations. GFCIs monitor the current flowing in a circuit and detect any leakage current to ground. If a leakage current exceeds a certain threshold, the GFCI will trip and interrupt the circuit, preventing electrical shock. Arc fault circuit interrupters, RFCIs, are a newer type of safety device that are designed to protect against arc faults, which are a common cause of electrical fires. Arc faults occur when electricity jumps between two conductors, creating a high-temperature arc that can ignite nearby combustible materials. RFCIs monitor the current flowing in a circuit and detect the characteristics of arc faults. If an arc fault is detected, the RFCI will trip and interrupt the circuit, preventing a fire. In addition to these general requirements, there are also specific code requirements for different types of electrical equipment and installations. For example, there are specific requirements for lighting fixtures, receptacles, switches, appliances, and electrical panels. It is essential to be familiar with these requirements and to ensure that all electrical equipment is installed in accordance with the NEC. When planning an electrical installation in a 90% new house, it is always best to consult with a qualified electrician. A qualified electrician can assess the existing electrical system, determine the appropriate wiring methods and equipment, and ensure that the installation complies with all applicable code requirements. They can also provide valuable advice on how to improve the energy efficiency and safety of the electrical system. Remember that electrical work can be dangerous, and it is always best to leave it to the professionals. Working with electricity requires specialized knowledge, skills, and tools, and it is essential to take all necessary precautions to prevent electrical shock and fire hazards. It is also important to obtain all necessary permits and inspections before starting any electrical work. The electrical permits and inspections are required by most jurisdictions to ensure that electrical work is performed safely and in accordance with the NEC. The inspection process involves a qualified electrical inspector examining the electrical installation to verify that it meets all applicable code requirements. If the installation passes inspection, the inspector will issue a certificate of compliance, which is required to obtain a certificate of occupancy for the house. Failure to obtain the necessary permits and inspections can result in fines, delays, and even legal action. In summary, when dealing with a 90% new house, it is generally required to run all new electrical wiring to comply with the National Electrical Code and ensure the safety of the home. While there may be limited exceptions where tapping into existing wiring is permitted, these exceptions are subject to strict conditions and require careful evaluation by a qualified electrician. It is always best to consult with a qualified electrician and obtain all necessary permits and inspections before starting any electrical work. Electrical installation should adhere to National Electrical Code 110.3, which covers examination, identification, installation, and use of equipment. This section underscores the importance of using electrical equipment according to its listing and labeling. Electrical equipment has to be installed and used per the instructions included in the listing or labeling. National Electrical Code Section 110.12 covers mechanical execution of work. Electrical work must be installed in a neat and workmanlike manner. This includes securing cables and raceways, properly terminating conductors, and ensuring that the equipment is installed level and plumb. Section 110.14 focuses on electrical connections. All electrical connections must be made with approved connectors and devices, and they must be properly tightened to ensure a secure and reliable connection. The use of wire nuts, terminal blocks, and other connectors must be appropriate for the type and size of conductors being connected. National Electrical Code Article 200 deals with the use and identification of grounded conductors. This article outlines the requirements for identifying and terminating the grounded conductor, which is typically the neutral wire. The grounded conductor must be insulated and identified by a white or grey color. National Electrical Code Article 210 provides the requirements for branch circuits. Branch circuits are the circuits that extend from the electrical panel to the various outlets, lighting fixtures, and appliances throughout the house. This article covers the types of branch circuits, the allowable loads on branch circuits, and the requirements for overcurrent protection. National Electrical Code Article 220 focuses on branch circuit, feeder, and service calculations. This article provides the methods for calculating the electrical load on branch circuits, feeders, and service entrances. These calculations are essential for determining the appropriate size of conductors and overcurrent protection devices. Article 230 covers services, which is the connection between the utility company's electrical supply and the house's electrical system. This article outlines the requirements for the service entrance, service conductors, and service equipment, including the main disconnect switch and overcurrent protection. National Electrical Code Article 250 deals with grounding and bonding. Grounding and bonding are critical for electrical safety, as they provide a low impedance path for fault current to return to the source, which helps to protect people and property from electrical shock and fire hazards. This article covers the requirements for grounding electrodes, grounding conductors, and bonding of metal parts. National Electrical Code Article 300 covers wiring methods. This article outlines the approved methods for installing electrical wiring, including the types of cables and raceways that are permitted. It also covers the requirements for protecting wiring from physical damage and environmental factors. Article 310 provides the requirements for conductors for general wiring. Conductors must be properly sized for the intended load, and they must be insulated to prevent electrical shock and fire hazards. This article covers the ampacity of conductors, which is the amount of current that a conductor can safely carry. National Electrical Code Article 314 focuses on outlet device, pole, and junction boxes, conduit bodies, fittings, and handheld enclosures. These boxes and enclosures are used to protect electrical connections and provide access for maintenance and repairs. This article covers the requirements for the size, type, and installation of these boxes and enclosures. National Electrical Code Article 404 covers switches, including snap switches, dimmer switches, and other types of controlled devices. This article outlines the requirements for the installation and wiring of switches, including the proper wiring methods and the requirements for grounding. National Electrical Code Article 406 deals with receptacles, cord connectors, and attachment plugs, which are commonly known as outlets. This article covers the requirements for the installation and wiring of receptacles, including the proper wiring methods and the requirements for grounding and ground fault protection. National Electrical Code Article 408 focuses on switchboards, switchgear, and panel boards. These are the electrical distribution centers that receive power from the service entrance and distribute it to the various branch circuits throughout the house. This article covers the requirements for the installation and wiring of panel boards, including the proper overcurrent protection and grounding. National Electrical Code Article 410 covers luminaires, lamp holders, and lamps, which are commonly known as lighting fixtures. This article outlines the requirements for the installation and wiring of lighting fixtures, including the proper wiring methods and the requirements for grounding and ground fault protection. National Electrical Code Article 422 deals with appliances. Appliances are electrical devices that perform a specific function, such as refrigerators, washing machines, and dishwashers. This article covers the requirements for the installation and wiring of appliances, including the proper wiring methods and the requirements for grounding and ground fault protection. Article 430 focuses on motors, motor circuits, and controllers. Motors are used to power a variety of equipment, such as pumps, fans, and compressors. This article outlines the requirements for the installation and wiring of motors, including the proper overcurrent protection and control devices. National Electrical Code Article 440 covers air conditioning and refrigerating equipment. Air conditioning and refrigerating equipment require special electrical considerations due to their high power consumption and the potential for hazardous conditions. This article outlines the requirements for the installation and wiring of this equipment, including the proper overcurrent protection and disconnecting means. National Electrical Code Article 547 deals with agricultural buildings. Agricultural buildings, such as barns and poultry houses, often have unique electrical requirements due to the presence of moisture, dust, and corrosive substances. This article outlines the requirements for the installation and wiring of electrical equipment in these buildings, including the use of special wiring methods and equipment. National Electrical Code Article 680 focuses on swimming pools, fountains, and similar installations. Swimming pools and fountains pose a significant electrical hazard due to the presence of water. This article outlines the requirements for the installation and wiring of electrical equipment in and around these installations, including the use of ground fault circuit interrupters and bonding. National Electrical Code Article 700 covers emergency systems. Emergency systems are designed to provide power to essential equipment during a power outage. This article outlines the requirements for the installation and wiring of emergency systems, including the use of generators, batteries, and automatic transfer switches. National Electrical Code Article 701 deals with legally required standby systems. Legally required standby systems are similar to emergency systems, but they are required by law to provide power to certain types of facilities, such as hospitals and nursing homes. This article outlines the requirements for the installation and wiring of these systems, including the use of generators, batteries, and automatic transfer switches. The National Electrical Code is a comprehensive document that covers a wide range of electrical topics. It is essential to be familiar with the code requirements and to follow them carefully to ensure the safety of electrical installations. Now let's talk about electrical permits and inspections. Electrical permits are required for most electrical work, including new installations, alterations, and repairs. The purpose of an electrical permit is to ensure that the electrical work is performed safely and in accordance with the National Electrical Code. To obtain an electrical permit, you must submit an application to the local building department or electrical inspector. The application will typically require information about the scope of work, the location of the work, and the name of the electrician or contractor performing the work. Once the application is approved, you will be issued an electrical permit. The electrical inspections are required after the electrical work has been completed. The purpose of an electrical inspection is to verify that the electrical work has been performed safely and in accordance with the National Electrical Code. The electrical inspector will examine the electrical installation to ensure that it meets all applicable code requirements. If the electrical installation passes inspection, the inspector will issue a certificate of compliance. It is important to note that electrical permits and inspections are required by most jurisdictions. Failure to obtain the necessary permits and inspections can result in fines, delays, and even legal action. Working with electricity can be dangerous, and it is always best to leave it to the professionals. A qualified electrician can assess the existing electrical system, determine the appropriate wiring methods and equipment, and ensure that the installation complies with all applicable code requirements. They can also provide valuable advice on how to improve the energy efficiency and safety of the electrical system. Remember, electrical safety is paramount. Always take the necessary precautions to prevent electrical shock and fire hazards. By following the National Electrical Code and working with a qualified electrician, you can ensure that your electrical system is safe, reliable, and capable of meeting the demands of your home.